Hi everybody, we're on to 12.2, which is the start of our exponential functions. Typical exponential function, come on, looks like this, x to the y, okay? Sometimes they say it is a to the x. Okay, so what that means is you've got like a function, let's just put one in there. That kind of looks weird, but 3 to the x would be an exponential function, okay? It's where the variable sits in the exponential spot. Let's take a look at what these look like. 3 raised to the x power. Okay? What these all do is every exponential, the characteristic trait of exponential functions is they'll rise real slow and then they'll shoot up. Okay? Things that in the real life that follow things like this would be, just as an example, disease. Right? In the beginning, we've got just a few people getting diseases and yeah, it's not so bad, and then all of a sudden the outbreak happens and it just goes rampant, right? And it starts growing like that. Mold and bacteria grow exponentially. And then you've also got, decay. That, it starts, up really high and it comes down and it shoots down real fast. Okay? So you could have kind of a steady thing and then just like that. Housing market, economy, sometimes that happens too. These are called J-curves. They kind of look like the letter J, like the letter J for J-curve. Anyway, we're again going to skim this. I've got 7 problems in here. There's so much to exponential functions that you will get into quite heavily later, but I just want you to be aware of them. Right now, we're not going to get into many of the applications for it. I think we're going to get into some money stuff, but that's about it. Okay? Radioactive decay, carbon dating, all kinds of things. They all rely on exponential functions. Okay? So right now, all we're going to do is we're going to evaluate the function at the given value. All right, well, this is just calculator work. It's super easy. We're just going to remind ourselves that we can take any number to any power. Okay, so if we're evaluating f of 4, we're going to replace the x with a 4 up in there. Okay, so we're going to take 4 raised to the 4th power, get an answer, and that's going to be doubled, multiplied by 2. So we've got 512 on that. You're probably wondering if I'm going to be giving you test questions like this on the final, and I will. I'll give you a few like this, like I said, I've really kept this section nice and easy, so. All right, same thing here, right? We're going to raise 1.8 to the 2.2 power, okay? And these aren't going to be nice and neat, but that's okay. Here's my power key. We're going to re-rounding. It says to round to the nearest hundredth, that's 2, so 3.64, okay? I'm really hoping that I'm laying off at the time that you need me to lay off so that you can take a little breather and get some studying in for the final. All right, so the one thing that we do use this for quite a bit is money, okay? When we put money in an account, let's just say we have a savings account and we have simple interest, that's an annual interest rate, then we have one type of formula. And then if it's compounded, then we have another type. So compounding means you get interest on your interest. All right, and if you're investing money, that's the type of account you want. All right, so let's get our formula out here. So our compound interest formula that calculates it, like this is what a bank does with a computer, is this, but we can calculate it out too, being the mathematicians that we are. Do you see how it's an exponential? All right, so let's get these letters defined. A is the amount that you will have after a certain time. P is the principal. Dollars invested. Okay, so let's say you invest $1,300. That's your P. That's how much money you give the bank in the beginning. R is the interest rate that the bank is willing to pay you. And this has to be in decimal form. Okay? They'll always give it to you as a percentage. Okay? So you're going to want to divide by 100 to get that into decimal form. Okay? Or move the decimal over 2. And then T is the number of years invested. Okay, so here we're investing for 10 years. All right. And then the last one is N. And that's the number of times per year that it's compounded. Okay? Now if it says that it's an annual interest, that means it's compounded once. So N is 1. So N basically disappears. Now some of these here, we're going to have a compounded quarterly, annual, or biannually, monthly, yearly, daily, you know, then N is not 1 any longer. Okay? All right, so we're just going to plug into this formula here. We want to know how much money we have after 10 years of investing $1,300 at 7%. Well, let's figure it out. The amount of money that I'm going to have is A, and I've got $1,300 to start out with. I've got 1 plus my rate. Remember, N is 1 here, so those don't count. Dividing by N or raising it to the first power if N is 1, either way, it doesn't really matter. So if my interest rate is 7%, my rate as a decimal is 0.07, and my T is my time. Okay? The only thing that's hard about this is making sure that we do this in the calculator correctly. Okay? You're going to want to do the inside of the parentheses first. Right? 1 plus 0.07. Then you want to do your exponent next. Then you want to do your multiplication last. Right? Please excuse my dear Aunt Sally. So after 10 years, you would have, money is always 2 decimals because that's considered pennies. Okay, you would have this much money. You'd have 30 cents. Okay, not 30 cents, 25, 57, and 30 cents. It's the rounding that I was talking about. Okay. Same thing here. We're going to invest $200, so that's what goes here. Right? We have an annual interest, so N is 1 again. We have 20%, which is 0.2, and your time is 19 years, and you just calculate it out. So let's do this one if it's compounded quarterly. I wonder if I can get this up just a bit. There, okay. So we want to know how much Don is going to have. So Don will have, he invested $6,000, right? And we have 1 plus, what's my interest rate? 6%, which is 0.06. We've got a compounded quarterly. That means 4 times a year, correct? Remember, number of times per year that it's compounded? If it's compounded quarterly, that means 4 times in the year. 6 years times 4, that's your N times T. Okay? And again, this is not difficult. This is going to be calculator work. I would do this in pieces. I would do the 0.06 first and divide that by 4. Okay? Then I would add a 1. Then I would raise that to the 6 times 4 power, or the 24th power. And then I would multiply that by 6,000. Now, if you want to do it differently, that's totally fine. But this is the way that I would put it in my calculator. 0.02, right? We've got 2 decimals. Okay, so this n is how many times per year. If it's compounded quarterly, that means 4. Weekly would be 52. Monthly would be 12. Daily would be 365. All right, so it just depends on the problem. All right, okay. So like I said, we're really getting into just a smattering of just different, nothing heavy here. So this is just one application. All right, I just chose one to do. Now the other thing that we have is this funny letter E. All right, and again, I'm not going to talk a lot about E. Okay, it's just when we have these special numbers in math, and like pi, for instance, is a very special number, right? It's 3.14 blah blah blah. It's irrational and it goes on forever, but it's very useful in circle stuff, right? Well, we have another number called E, and this is, again, it's not a letter, it's a number. Blah 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 blah. It's also irrational. All right. So let's try to find out first of all what E is. All right. E is right there on your calculator. Do you see it above your division sign? So if we just did second function E and got a value for it, we can see that it's 2.7182818828. Looks like it has a pattern, but it doesn't. Okay, so it goes on forever, just like pi would. All right. And again, it comes from the compounding. It's just a natural number that occurs in mathematics, just like pi does. So I don't want to get too deep in it. And then we also have a e to the x key, which is right here, e to the x. That'll raise e to any number. All right? So you could either use e here and use your power key raising, or you can just use this one here, which is a little faster. So if we want to do, we have f of x is equal to e to the x, and we want to evaluate f at 1.3, we're just going to replace x with 1.3. And I never want you to put the 2.72 in there. I want you to use your e key. E key. Okay, we want to raise e to the 1.3 power. Okay, 3.100th is 267, let's say. 3.67. All right. So it'd be like raising pi to some number. Yeah, we can do that. Okay, we have f of x is equal to 1 minus e to the x, and we want to evaluate x at -2, and we would just replace the x with a -2. Okay, 1 minus e to the x to a -2. Done. Nearest hundredth would be 0.86. 0.86. Okay? All right, we also are going to be talking about what an e is as far as logarithms go, because it's one of the two bases that we use. Okay? And like I said, I don't want to get too deep into this stuff. We're just going to skim it. Right now, I just want you to know that there is such a thing as e. It occurs in all kinds of applications, and we do have the power to raise it or use it to solve or in logarithms for right now. So, all right, so that's it for 12.2, and I'll see you for 12.3.